Good evening, everybody. My name is Isaac, and here my fellow
Rafael.
And through this video, we're gonna be your teachers. We're gonna explain you the application of Riemann sums. So, we're gonna analyze the problem. In point A, the problem is asking you to get the approximate of this integral right here by using the midpoint Riemann sum.
In the second step, you need to find and explain the meaning of this approximation. As you can see, we have the time and the velocity. The time is the x-axis and the velocity is the y-axis.
And finally, in point C, we're gonna explain what's the meaning of this thing right here, like in problem B.
Okay, the first thing that we need to do is to locate delta x. The formula to delta x is v minus a divided by n. In this case, the v are 40 and the a is 0. And finally, the n is 4 because we need to check that is 4 sub-intervals. Then we substitute the values in the formula.
So now that we get our delta x, we get the intervals in this table. As it's 10, the first interval is from 0 to 10. The second is to 10 to 20, and then 20 to 30, and then 30 to 40. But as the problem is asking us to use a midpoint Riemann sums, the points that we are going to get is those points between those two intervals. So the points are 5, 17, 25, and 35. So we do the Riemann sums. And this is our answer. The answer is in meters because the Riemann sum is like a integration. So we get the approximation of that integral, and as it is the integral of bt, the answer is s of t. That means position. So that's why our answer is in meters.
The next part is to get the value of this formula. This formula says that we need to take the value of b of 40 and b of 0. In this case, is 100 and 120. Finally, we need to get the conversion. The final answer is 0.5.
So we got the answer for the formula, but we still don't know what this 0.5 means. So we're gonna explain what does that mean. In this formula, it's asking us for a value in y, for two values in y, this one and this one. This one, we're gonna call it y of 2, and this one we're gonna call it y1, and that's over this value of 40 that it's in the x-axis or the time axis. So we're gonna call it x2 and minus another point in x that it's 0. We're gonna call it x1, and as you can see, this formula right here is the formula to get the slope of a function, and the slope it's the derivative of a function. So in this case, we got the derivative of b of t, and the derivative of b of t is a of t, that is acceleration, and we can prove this in this formula of acceleration. Acceleration is final velocity minus initial velocity over time 2 minus time 1, and we did it in this formula right here, in this formula, and we got 0.5 acceleration.
Finally, the question is to get and explain the meaning of integral of minute t divided by 40, that is all the time in the table. Well, we know the integral of minute t, that is 6,120 meters, and we know all the time, that is 40. Finally, we substitute the values in the formula. The answer of the formula is 153 meters
Per second.
per second.
Meters per second. And the answer is the velocity, but it is the average velocity because it's all the displacement over all of the time. So our answer is 153 meters per second. That is average velocity.